Hi everyone, thank you for coming. Welcome to a deep dive into Long Island's aquifers. I'd like to introduce today's speaker, Sarah Meyland. Give a little background first. Ms. Meyland is a water specialist with a background in groundwater protection, water resources management, water quality, and environmental law. She was an associate professor in the Department of Environmental Technology and Sustainability at New York Institute of Technology, where she taught in the Master of Science program for over 20 years. Professor Meyland has worked in New York State government as the co-executive director of the New York State Legislative Commission on Water Resources Needs of Long Island. She was the watershed director for the Suffolk County Water Authority and the program coordinator for the Nassau County Planning Federation. She also served as executive director of Citizens Campaign for the Environment, a nonprofit organization. In addition, Ms. Meyland has served on the New York State Drinking Water Quality Council since she was appointed in September 2017. Ms. Meyland has a law degree from St. John's School of Law, a master's degree in water resources management from Texas A&M University, and both a BA degree in marine biology and a BS in geological oceanography from Cal Poly Humboldt. We are very lucky to share her vast experience and knowledge. Please hold your questions until the end of the presentation. Thank you.
Someone bring the here on the Zoom. I believe the microphone's over there.
Just for a second, I'm just adjusting the microphone settings because some people said it's hard to hear.
Well, since the speaker's facing away from the microphone, they're not going to hear.
Microphone's right here.
So let me just choose this. Input device.
The volume level? Upper right. See the upper right?
That's the speaker volume.
We won't be able to hear that.
Maybe I'm just going to raise the speaker volume. Let me go back to the presentation. Sorry about that, folks. Audio settings. Audio settings. Input level.
There's a test mic button.
Oh, that's not what
Recording
they're
done.
not what they're going to hear.
Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Testing 1
There
2
you
3.
go.
I didn't change anything, so I think that's fine. But I don't know how to
And
raise
this is the speaker wasn't talking to the microphone.
right.
Do
And
you
the
want
mic.
to say to the people on Zoom if they could write in the chat if they now hear?
Yeah.
That made a difference,
Yeah.
just so we know.
We're
Folks-
going to say it out loud.
Folks online, can you just everyone on the Zoom meeting is
If you type in the chat that you hear us.
yes.
Well, somebody just moved.
Folks on Zoom meeting, can you hear us now? Can you please type in the chat if you can hear us or not?
I can hear you. It's just the chat thing's hard to use with my visual issues. So, yeah, I hear you.
Or you can type in the chat, you can say, or you can type message here. You can just say, can you hear us?
Okay.
Let's see if that works. Oh, I can hear, okay.
And then your message.
All right, somebody said I can hear. Woo!
There we go.
Sorry about that.
Okay, so
All right, perfect.
We're recording. Now we're going to go to screen share.
Thank you, Jen wrote out your back, you can see it.
Awesome. PowerPoint slideshow. Share. And hide.
All right. Woo-hoo.
about that time.
There
Good
you go.
job, thank you,
Okay.
thank you.
There you go, Miss Meyland.
And you want to get the lights?
Oh, yeah, we'll switch the lights over.
So for those of you who are online, I'm sorry you're going to see my back for a while. But good afternoon, good morning, everyone, and thank you for inviting me to talk to you today. And as Gail said, I'm going to be talking about the aquifer system here on Long Island. And this is what I'd like to cover with you today. First of all, just to go over basic information about the groundwater system. Talk about the challenges we have with regard to our water supply. Go over some new information about water quality and some other interesting issues that have come up recently. And then I'd be happy to take any questions that you have. Can everyone hear me okay?
Yes.
Yes.
So first of all, let me just go over some basic terminology because you've probably heard a lot of terms that are thrown around when people talk about water issues. So just to clarify everything, the first question I want to answer is what is groundwater? And it's really basically very simple. Groundwater is the water that's stored underground in formations that we call aquifers. So then what is an aquifer? Well, it is a geologic formation that can perform three functions. First, it can store water. Second, the water can flow through it, which is called the ability to transmit water. And last, you have to get the water back out, and that's called yielding the water back in usable quantities. So we have lots of different formations that can do some of these, but if they can't do all three, it's not an aquifer. And so we have some examples of that here on Long Island as well. Where does all this groundwater come from? Well, it begins as rainfall. So rain falling on Long Island has a future of becoming groundwater. What is the water table? Well, water table is the word we use to describe the very top surface of the water that's in the groundwater. So the top surface of the groundwater we call the water table. It's not necessarily flat, but that's the term we use. What are aquifers made of? Well, they can be made of all sorts of geological material. It can be sand, gravel, sandstone, limestone, solid rock that's fractured. There are many, many types of things that can serve as an aquifer. On Long Island, our aquifer is made up of sand and gravel. And where is the water that's in the aquifer? Is it in a lake somewhere underground? Is it in a river? Well, because we have a sand and gravel aquifer, the water is in the sand, but what that really means is that we all know what sand looks like. We've been to the beach. It's made up of tiny little particles of silicon very often. So there's a space between each grain of sand. That microscopic space is where all the water is stored. So if you've ever been to the beach and you've dug a hole in the sand, if you dig down far enough, it doesn't take very long for that hole that you've created to fill up with water. That water drained out of the sand and filled up the hole. And that's kind of the way the groundwater system works. You put a well in the ground, it's a hollow space, the water seeps out of the sand, fills up that hollow space, and then we pump it out. So all of the water that we use is stored in the sand beneath our feet across Long Island. What is the drinking water made up of? Well, it's made up again of rainfall. And that water that you're going to drink from your faucet can be many different ages. It can be 25 years old, it can be 50 or 100 years old. It could be literally thousands of years old. It depends on how deep the well was that withdrew the water and where around Long Island that well is located. So there's no rule about how old your water is. It depends on the location that withdrew it from the aquifer system. And how does the water get to your home? Well, there's obviously an underground infrastructure, and it's made up of a number of components. You'll see over here, right here at A, that's where the water is coming into the water system. And typically that is going to be a well. And there'll be a pump house sitting on the land surface, and usually the well is right below the pump house, and it's pulling the water out of the aquifer into the pump house. And there's a certain amount of treatment that goes on here with disinfection. And then the water, in some cases, is going to be pumped up into a storage tank. And that's for backup water. And also, this water above ground level elevation creates the pressure that pushes the water through the water mains and down into your home. So it isn't the pumps that create that pressure, it's the elevated water. And that's why you see these water towers all over Long Island. This is the engine that uses the force of gravity and creates pressure to push the water into your home. So it's a very efficient and low energy solution to moving the water around. This is a typical diagram of what the groundwater system looks like, the aquifer system. And you'll see that actually we have three main aquifers on Long Island that together make an aquifer system. So the topmost aquifer that's closest to the ground surface is called the upper glacial aquifer. It can be anywhere from about 50 to a couple of 100 feet thick or more. And so all of the rainfall enters the groundwater system by passing through the upper glacial aquifer. And then that aquifer sits directly upon the largest aquifer, which is directly below it, which is the Magathy. So the upper glacial formation is about 10,000 or more years old. The Magathy aquifer is about 70 million years old, the formation itself. And the middle of the Magathy, in the middle of the island, is about 500 feet deep. So it's much shallower on the North Shore, and it's much deeper, can go down to about 1,000 feet on the South Shore in depth. So this aquifer, the Magathy, holds the largest amount of water in the total system. Nassau County gets about 90% of their water from the Magathy. Suffolk County is about 40% upper glacial and about 60% Magathy. And then at the very last aquifer system is at the bottom of the overall aquifer, and it's the oldest formation. It has the cleanest, the purest water left on Long Island, and the deep part of the Lloyd aquifer can be as much as 2,000 feet below land surface, and the water down there can be 8,000 years old, which is saying that it took 8,000 years for that water to start as rainfall and slowly migrate its way down through the formations and then travel to the South Shore. So the water down on the South Shore is deeper than the water up here on the North Shore, and it can get to be much older because that travel time took it a longer amount of time to get through the whole system. And so you'll see that the formations are kind of like layer cakes, but they're slightly tilted. And so that's what they really are. They're layers of sand sitting on top of one another. And then we have a clay system along the South Shore called the Gardener's clay, and a big thick layer of clay called the Raritan clay. And they can be a couple of 100 feet thick. They are not aquifers. They hold water. Water can slowly move through them, but you really can't put a well into them and draw much usable water out. So they are not aquifers. They're actually barriers to water flow, but they're there nevertheless, and they provide some protection to the aquifers that are beneath them. And there's a small aquifer down here on the South Shore called the Jamico that sits under the Gardener's clay and is protected by the Gardener's clay. So that's the system in its totality, and so we'll talk a little bit more about that later on. This is another picture of looking at our access to the aquifer system. This is a map of where the wells are on Long Island, and you can see all of the green dots are indicating well sites that are either glacial wells or Magathy wells. And you can see the vast majority of wells on Long Island are tapping into one of those two systems. You'll see up here on the North Shore, especially in Nassau County, which is right here, you'll see some blue squares. These are Lloyd wells. And you'll see some red squares, which are old Lloyd wells that have been abandoned and are not used anymore. So the bulk of the Lloyd access is along the North Shore of Nassau County and a little bit along the boundary between Nassau and Queens. And then in Queens, you can see this cluster of wells right here. This is the old Jamaica water supply system that was well water that pumped water for about 100 years. And it's shut down now, but the pumping impact from those wells has done tremendous damage to the groundwater system, including causing saltwater intrusion problems. Can you hold your
I know we weren't
question?
supposed to ask a question till later, but the previous diagram didn't delineate the extent that it didn't have the Lloyd on it. Now, I know what it is personally, but
Here's the Lloyd
for
right here.
anyone else in the room, it didn't really.
Here's the Lloyd.
All right. That's, I heard, yeah, all right, all the way down there. All right.
Okay. And you'll see on this slide, there's this big red line that runs down through the middle of the island and then out onto the forks. That's an imaginary line that's called the groundwater divide. And it divides the Long Island aquifer system into two big watersheds. One on the North Shore, and all the rain falling to the north of this line flows to the Sound, and all the water on the south side flows to the Atlantic Ocean. And this is roughly along the route of the Long Island Expressway. Get a feeling for where that is. So it's actually shifted a little bit north of where this line is drawn. And then we see a similar thing that goes on out on the forks. So groundwater is constantly moving away from the source and out to a discharge point, which is typically going to be either Long Island Sound, the Atlantic Ocean, or into the Peconic Bay area. And you can see that there are a lot of wells that are tapping into this water. So there are over 400 public water supply wells in Nassau, over 600 in Suffolk. There are thousands of industrial and irrigation wells into the aquifer. There are over 5,000 groundwater heat pump wells, and there are about 40,000 private home wells out on the east end. So there are a lot of ways by a lot of different users that are bringing water out of the aquifer system. I'm just going to go through this really quickly. We talk about surface water, we talk about groundwater. They're not the same thing, and they don't follow the same rules. So New York City is primarily a surface water system. It brings this water down from the Catskills and so forth. That water is stored on the land surface, so it's in reservoirs and lakes, which is easily visible. It's easy to access surface water. It's available to be contaminated by airborne pollution and discharges. One thing that is very different from groundwater is that surface water tends to flow, oops, get this right, very fast in what's called turbulent or chaotic flow. So the water's just kind of boiling along as it moves through a stream. And it moves in terms of feet per second. But the thing about being turbulent flow and flowing very fast is that pollution gets diluted very well through the entire water body. In terms of treatment, there are set types of technology used. Every water is chlorinated. Typically, surface water goes through a sand filtration system. Sometimes disinfection uses ultraviolet light and other technologies. So that's surface water. That's what New York City uses. Groundwater is what Long Island uses. So here, all of our water is stored underground in these aquifer formations. It's not directly visible. It's not easy to access. It's not easy to monitor. It is vulnerable to pollution, but only pollution that will be dissolved in water. So the contaminants that we deal with in groundwater have been able to enter the groundwater system by being dissolved in water or being liquid to start with. The ground itself does not provide an ability to remove the chemicals that are dissolved in water or that are liquid. So those are the kind of chemicals that show up in groundwater as pollution. Groundwater flows very slowly. So we measure it in units of feet per day rather than feet per second. So a fast-moving surface water system, you cannot walk fast enough to keep up with it. In a groundwater system, you can't walk slow enough to be as slow as groundwater. And when pollution gets into it, it doesn't mix throughout the entire system. It goes from where the source was that provided the pollution and more or less streams away from that in a ribbon of pollution, we call them plumes, and flows in a more or less straight line from the source to where it either is pumped out or is discharged. So we have pollution plumes in groundwater. And the technology that we use to treat groundwater, chlorination, which all the water has to do, and then some various technologies, which I'm going to talk about next. So when we talk about water being filtered, we don't mean the same thing when we say that for a surface water system versus a groundwater system. We already have the world's largest sand filter as the aquifer system of Long Island. So it filters particles, but it doesn't filter chemicals. Same thing for surface water. The sand filtration is filtering particles because surface water carries a lot of sediment and things that are just suspended in the water supply. So these are some of the standard technologies we use to treat groundwater on Long Island. You have to match the pollution that you want to treat with the technology that does that. So the two most common treatment technologies are these blue tanks here. These are granular activated carbon units. There are two of them side by side. They treat VOCs, volatile organic chemicals. PFAS, which we're going to talk about, will use this technology. So it's very commonly used, especially in Suffolk County. It's almost exclusively what they use. And it's filled with little bits of charcoal, about the size of your fingernail. The tank is full of charcoal. You fill the tank with water, you let it sit for 30 minutes or whatever, and then you drain the water out, and the pollution has now attached itself to the carbon pieces, and it stays behind. And at a certain point, then you remove all the carbon, put in new carbon, and start over again. So very often you'll see these units in tandem, and they kind of piggyback. The water goes in one, then goes out the other, and that's the way it works. So this is what many people in Suffolk have as a treatment technology. In Nassau, this is one of the favored technologies, which is this big tower. It's called a pack tower or an air stripping tower. And at the top of the tower is a spray unit like a shower head. At the bottom of the unit is a big fan. And inside the tower are little plastic shapes that we call media. And they can have a lot of different shapes, but you see they're more or less plastic things like a wiffle ball or something like that that creates a surface area. And so the tower is full of these media. The water comes out the top of the tower and filters down by trickling down over the surface of these little plastic forms. And the air is streaming up from the bottom of the tower, blowing across the water surface of these media. And it literally blows the molecules of the contaminants out of the water and into the airstream and out the top of the tower. We have these all over Nassau County. The reason is that these are custom designed to meet the degree of contamination. These are standard off the shelf. They treat whatever they treat, and there's no design involved other than just getting them installed. This technology at the bottom down here is the latest thing. We have never used this technology before until we had to start treating for 1,4-dioxane, which is a new emerging contaminant. It's called an AOP, Advanced Oxidation Process System. It combines hydrogen peroxide with ultraviolet radiation, and that combination essentially explodes the 1,4-dioxane molecule. And then you drain the water out, and you may have to then send that water back through a GAC to get everything else out of the system. So it can be very involved. And these technologies, these two standard technologies, are fairly simple. This one is very touchy and very hard to get just right. So this is a little more complicated. In addition, we've got some technology like this one up here on the upper left, which is a reverse osmosis system. This is a membrane technology, so it allows certain types of materials to flow through it, like clean water, and holds back the pollutant that you want to get rid of, such as nitrates. So nitrate removal systems, such as those used here in Suffolk County, use a commercial version of this. It can also be used for desalination. And the last one is an ultraviolet system. So it looks like a fluorescent light tube, except instead of emitting visible light, it's emitting UV light, which is will kill pathogens. So sometimes it's used for water disinfection. And it's also the technology that's installed in this AOP system. So part of the system has these UV light tubes in it. So this is the menu of all the different kind of chemicals that can be found in the raw groundwater beneath Long Island. No place has all of these at once. Typically, a location can have one or a couple of these types of chemical pollutants as a problem that you then have to match the treatment technology to get it out so that the water can be provided to the public. But you can see that we've got quite an assortment of chemicals challenging our ability to provide clean water. So when we talk about the contaminants in the groundwater, we're not necessarily saying that it is also in the drinking water, because the water suppliers have to take it out to make the water drinkable. So our raw water is heavily and increasingly heavily challenged, impacted because we live over our water. And so the extent to which we are messy on the land produces the contamination below where we're living. And that's just as simple as it gets. We're messy, we're careless, we dispose of things we shouldn't on the land, and it gets in the rain and it gets into the groundwater. That's the connection. And so we have to get these things out in order to keep the aquifer available to us for a water supply. The more we disrespect this resource by being careless and ambivalent, this puts our water supply at risk. So I said that groundwater flows in a straight line and creates what we call a groundwater plume. So here's septic tanks from houses that are spread out across the landscape. The wastewater leaves the septic system, travels through the soil, hits the water table, gets into the groundwater system, and then starts moving away from the source in a straight line, more or less, in a plume. As long as the sources are spread apart like this, each individual plume is not doing, irreversible harm. But when you get houses packed all together, and so you have a lot of sources concentrated in an area, then these plumes come together and they create real problems in terms of water quality. And the plume will go on until it either stabilizes, hits a well that has to now be remediated, or discharges into a stream or the shoreline areas or whatever. And we have another issue that is a combination of quality and quantity. So saltwater intrusion is an issue that is ultimately related to water quality, because if the water gets too salty, we can't drink it. So that's a quality problem. But it is driven by a quantity problem of overpumping the aquifer. It allows the ocean to invade our aquifer system, turning it salty so that we can't use that portion of the aquifer. So saltwater intrusion is a big issue on Long Island, more so in Nassau than in Suffolk. But basically what is happening is that we're overpumping the aquifer in areas, dropping the water table. The fresh water is constantly trying to push out into the coastal waters, whether it's the Sound or the Atlantic Ocean, at the same time that the ocean is pushing its way in. And there's this meeting zone that we call the interface, the saltwater interface, that gradually changes from fresh water to brackish water to salt water. And it's not that big an area. It's not like it's a half a mile wide, or it's much more narrower than that. But what is holding the ocean back is the amount of water in storage in the aquifer, which is pushing out. And if everything is stable, this boundary line is stable, and the ocean stays where it should be, and the fresh water moves through the system. We're overpumping parts of the aquifer, destabilizing the saltwater interface so that the ocean wins that pushing match, and it invades the aquifer. So here's an example of that. We can see that the old water table was up here. The new water table is down here. So overpumping has drawn down the total amount of water stored in the aquifer. The old saltwater interface was over here, and this was fresh water. But because we've drawn so much water out of the system, the fresh water couldn't hold the ocean back, and it invaded inland beneath the land surface. And so this well that was once drawing fresh water now is contaminated with salt water, and it can't be used anymore. And you'll see that in an intrusion like this, which we have in Nassau County, you see this is kind of like a vertical line here. When you start to get intrusion, the deeper part of the intrusion leads the invasion of the aquifer, and the shallowest part holds back. And that's because the salt water is heavier than fresh water, so it shoves its way along whatever surface is down here and it invades further inland than the top of the intrusion zone. And so this is what we see happening in Nassau County. This is a map in Nassau County of intrusion areas. So all these yellow areas are intrusion into the Lloyd Aquifer. This big orange area down here in the southwest corner of Nassau County is intrusion into the Magathie, and this intrusion was caused by the pumping over here in Queens that we talked about just a minute ago. So our current knowledge of the totality of the groundwater system of Long Island is very much out of date. It's about 35 years old. So a couple of years ago, a new study was undertaken to better refine our understanding of the groundwater system and figure out where saltwater intrusion was now occurring across all of Long Island. So that's an ongoing study. And they're looking at intrusion both for the Magathie and the Lloyd. The study hasn't released its first report yet, but a preliminary report came out a couple of years ago, and this was one of the maps that they produced. And what we see is these wavy lines here. So this is Brooklyn, this is Queens, and this is Nassau over here. And we've got wavy lines indicating saltwater, active saltwater intrusion. There's a yellow line, an orange line, and a red line. I know it's probably hard for you to see all of them, but the red line represents the deep Magathie. And so this is looking at saltwater intrusion in the deep Magathie that has really gone into the center of Queens and has cut through this corner here on the southwest corner of Nassau, which was that map we just looked at, this one right here. And this is dramatic for two reasons. One, we never understood until this study that intrusion had invaded such a substantial part of Queens. And it's largely made the well system in Queens unusable. New York City was prepared to spend many, many, many millions of dollars to rehabilitate these wells. But now that they see this, they know that it's a lost cause. Now, saltwater intrusion creates a chloride contaminant in the water, and that's how we monitor saltwater intrusion, by sampling for chlorides. The chloride drinking water standard is 250 parts per million. These lines represent contamination of 5,000 parts per million. So it's very significant intrusion into parts of the aquifer system. So in review, we have different types of intrusion. The one I've talked about so far is what we see in Nassau County, where we've got more or less a wall of saltwater invading the freshwater parts of the aquifer. The bottom of that wall precedes the rest of the intrusion down here in the deep part of the aquifer system. And it advances more or less as a front into the aquifer, and we call this lateral intrusion. We have saltwater intrusion in Suffolk County, but it occurs on the east end, on the forks. And the aquifer system out on the forks is different than the main part of the island. And so when you go out on the forks and you drill a well deeper and deeper, you will hit an area of the aquifer that is already filled with salt water. So all of the deep, deep water beneath, groundwater beneath the forks is salty. And so all you have to work with is what we call a bubble of fresh water that is floating on salty groundwater beneath it. And so this bubble of fresh water is lighter than salt water, and that's why it can sit and be relatively stable above the salty groundwater beneath it. However, It's not very large. The water table is not very high above sea level. And so you cannot put the kind of well that we would put in the middle of Suffolk County into the forks. It's drawing too much water and it goes too deep. So you have to put a bunch of small wells that don't draw that much water. And if you aren't careful, you'll destabilize the interface at the bottom of the bubble and get this peak of salty water pulling upward toward the well. And if you don't pay attention, you'll ruin the well because salt water would have come up from the bottom up into that well pump zone. And this is called upconing intrusion. So this little peak or finger of salt water coming up, approaching the well is called an upconing type of intrusion. So that's what we have out on the forks. So to put all of this together, basically the groundwater system likes to be in balance, meaning that the water coming in through rain and the water going out in a variety of ways, that equation of water in, water out needs to be in balance. So this is the equation. Water in, we call inflow, that's the recharge right here, rainfall. All of that water coming into the system needs to be equal to or greater than all of the water leaving the system in the various ways that it can leave the system. If this gets out of balance, then we take extra water out of storage to balance things out again. And the system responds by dropping the water table, drying up streams, all sorts of ways to get the equation to work again. So in Nassau, this is out of balance. In Suffolk, it's not out of balance yet. And so whether they're humans on the island or not, every minute water is leaving the aquifer. It's going into streams, it's going into lakes and ponds, it's going into the estuaries and coastal waters, it's going out into the ocean floor. So the system was normally in balance with that combination of in, out. But then humans come along and they on their own start taking a lot of extra water out of the system, which is the driving factor to making this equation no longer in balance. So the system is trying to get in balance, so that's why we get saltwater intrusion. That's why we see streams and ponds and lakes dry up. There was another study that just finished up called the North Atlantic Coastal Plain Study that went from mid-North Carolina all the way up to the end of Long Island. These are all communities that rely on groundwater, and the study was intended to look at how are all these communities doing? Are the aquifers being overpumped? What's the water supply? And so forth. So it looked at every place and it found that of all of these communities from North Carolina to Long Island was the most heavily developed. Over 65% of the land area is already covered with human development. In turn, what that meant was that Long Island, compared to all of these areas, had the highest per person water use of this entire part of the United States. And when you compare Long Island with every place else in the country, we're also pretty much at the top of the list of high water use areas. Around the country, 100 gallons a day is a very typical average per person amount of water or less. On Long Island, the average water use is 130 gallons per person per day. And in the summer, it goes way, way, way above this. So we are extravagant in the way we use water and in the way we waste water. Obviously, from year to year, rainfall varies, and also recharge, getting that rainfall back into the ground varies. This is just some of the recent years, and you can see there's a big fluctuation between very rainy years and very dry years. So the average rainfall in Suffolk County per year is about 46 inches per year. which is very plentiful, when you look around the country as to what people get in terms of rain. Half of that ends up getting into the groundwater system, which is great. Now, we have two types of water year. We have the winter water year and we have the summer water year. Winter is October 1st to the end of April. Summer is from May 1st to the end of September. Virtually all of the water that replaces the water that we take out from the aquifer occurs in the winter months. Why? Because there are no plants. We're not watering the grass. So, and we get good rainfall during that time period, or snow. And so this is the key time when water is replenishing the aquifer system. In the summer, virtually no recharge is happening because plants are growing, we're watering the lawn, we're doing all these summer activities, and they rob the water that would normally go to the aquifer. They rob that water getting to the aquifer system. So in the summer, we have lots of hot weather, lots of pumping. The pumping goes way, way, way up. And the aquifer gets a double whammy. It gets no recharge, and it gets huge drawdown from water use. Last year, the Suffolk County Water Authority pumped 71.9 billion gallons of water. So double that for Nassau County, and you can see that we're taking billions and billions and billions of gallons of water out of the groundwater system every year. I don't know if you've been following it, but the New York Times has been doing a really great series of articles about groundwater use around the United States. Had a little blurb on Long Island. They said Long Island and New York, saltwater is encroaching on parts of the aquifer that provides water to 3 million people. It noted that Suffolk County has had to limit their pumping on about 60 of their wells because of the drop in the water table, the fragile nature of the water out on the east end. So water suppliers are having to deal with the consequences of overpumping even here on Long Island. So what I'd like to do is to shift gears very fast, because I know I'm getting to the end of my time, and talk to you about water quality for a minute. You saw the list of all the different kind of contaminants that we find in different places around Long Island, but everybody is concerned about what we call emerging contaminants. These are contaminants that were never regulated, that in most cases we were completely unaware that they could be in the water supply. And only recently did we start to look for them, and when we looked, we started to find them. So in New York has led the nation in dealing with some of these contaminants that we are now regulating through the state drinking water laws. So we currently are regulating 1,4-dioxane, and we're regulating 2 PFAS chemicals, PFOA and PFOS. The standard, which we call an MCL, maximum contaminant level, the standard for 1,4-dioxane is 1 part per billion. And typically that has been the lowest that we would go to regulate a drinking water contaminant. However, that has changed. Now for PFOA, PFOS, we're regulating it at 10 parts per trillion. You can't even imagine what a small amount of contamination that is. And we're regulating drinking water to that level. Now, in addition, since these standards were set last year, a lot has happened. New York is getting ready to add 4 additional PFAS chemicals to be regulated. We're in that process right now. It's probably going to be, again, a 10 part per trillion standard to match the ones we already have, but it's not a done deal yet. In addition, we're going to add a whole list of new PFAS chemicals that all suppliers have to test for, and if they find them at certain levels, they're going to have to tell their customers, hey, we want you to know we found these new chemicals in our water supply wells. Now that makes a lot of sense, except that something else has happened, which is at the federal level, the EPA had said years ago, we're not dealing with PFAS. We're not going to regulate it. You know, you're on your own. Recently, the EPA has come back around and said, no, we've changed our mind. PFAS is very problematic. We shouldn't be exposed to PFAS at all. And we're proposing that we're going to regulate certain PFAS chemicals at 4 parts per trillion, which is well below what we're doing in New York right now. So it's a little bit up in the air if EPA is going to get there first, or if New York is going to go ahead and bite the bullet and do what they're going to do, and then the feds will come along and adopt whatever standard they see they want to do. But the goal here, which is really important, is that the feds are saying people should have a 0 level of exposure to these PFAS chemicals. And they're being very clear about that we've not put enough emphasis on keeping people protected from PFAS. So how has this affected Long Island? The chemicals that are causing problems in the 2 counties are not the same chemical. So in Nassau County, 1,4-dioxane is the big chemical problem. 17 different water suppliers have found 1,4-dioxane at levels 1 part per billion or more. And this is water suppliers, so one supplier could have 5 or 6 wells in their system alone that has to be treated for 1,4-dioxane. 8 suppliers have found PFOA, and 7 suppliers have found PFAS also, and they're having to treat for that. In Suffolk, it's just the opposite. There is some detection of 1,4-dioxane, but PFOA and PFAS are being found much more widely than 1,4-dioxane, and there's a clear reason for the difference. And that is that, remember I said, one of the things we treat for a lot is VOCs, volatile organic compounds. Dioxin was a component of VOCs. So where you had a lot of VOC contamination, like in Nassau, that dioxane leached out, and now it's a pollutant all by itself. And so the places that had a legacy of VOCs are now showing a legacy of 1,4-dioxane. So PFAS is the bigger category of pollutants within which PFOA and PFOS are part, and PFAS stands for per and polyfluoroalkyl substances, PFAS. There are over 9,000 chemicals that are in this chemical family. They're very persistent in the environment. That's why they're called forever chemicals. They don't break down easily. They're very mobile in water. And we are exposed to PFAS from the time we're born, and actually before we're born, to the time we die. And we all have some level of PFAS chemicals in our bodies. So unlike 1,4-dioxane, which is shed from your body fairly quickly, PFAS chemicals can linger and stay in your body for many years because we're constantly being re-exposed to it. And these are some of the different kind of products that will find PFAS as a component of those products. So the other thing about PFAS that makes it difficult to talk about is the chemicals that are in this big family are impossible to pronounce or remember what they are. And so we just use PFAS as kind of the generic way to talk about them. But these are the 4 chemicals that New York State is looking to add to our regulatory scheme. And what makes these notable is that you can see the chemical formulas over here, and they're a combination of carbon atoms and fluorine atoms. And the more carbon that they have, the longer the molecule. And the longer molecules are the more dangerous molecules. These stay in the body the longest amount of time and have the potential to be most harmful. Just to give you a sense of that, the long chain half-lives for these chemicals can be anywhere from 1.2 years to a half-life of almost 13 years. So that's just getting rid of half of it. And you're probably being re-exposed so that, you know, it never really goes away. And it's not just humans that are getting these chemicals in them. Animals, food, all sorts of things now carry a load of PFAS. So that's really, I just wanted to give you a heads up about, a lot of people have questions about these chemicals, what's happening, you know, should we be concerned? So that's the story for now for PFAS. And just one more note, which is, I don't know if you saw this study, it was in some of the local papers. There was a recent assessment of how much groundwater is being pumped out of aquifer systems all across the world. And what they found was so much groundwater is being pumped out of storage, which may have been there centuries, that it is affecting, the rotational tilt of the planet. And it is also having effect on sea level rise, because that water is then going back into the ocean. So, you know, we don't really think about the big picture, but this is a classic example of everything is really connected one way or another. So I'm going to stop there, and if you have any questions, I'd be happy to answer them. Yes.
What kind of water filter do you use?
I do not use water filters whatsoever. I drink the water out of the tap.
Okay.
Should I stop the presentation and go back to camera mode?
If you'd like to, that would be fine.
And with lights back on.
I have a
Thanks so much.
question.
So let's give a round of applause.
Yes.
So I know this is a loaded question, but the lay person who wants to say, what small thing can I do to do my part, and can I tell people? What's the advice you would give for that?
Okay. Don't put any chemicals on the land, number one. Number two, read your water bill and notice not how much you're paying, notice how much water you are using. And now all water bills have to show your water use in gallons. So get familiar with your own water use. You're going to be shocked when you look at what water you used in the winter versus what water you used in the summer. And if you have an in-ground irrigation system, get a smart, modern, up-to-date controller and set it so that you are conserving the greatest amount of water you can, while still, if you feel compelled to nourish your lawn with water, use as little as possible, because we get abundant water on Long Island. We get 3 to 4 inches every month, which is plenty of water for most plants. Don't plant the same old grass that has to be watered. There's so many options now. So tall fescue is a good transition from Kentucky bluegrass. So plant different plants. Don't water everything. It doesn't need to be watered. Get a smart controller. Don't put chemicals on the lawn. Read your water bill so you know what you're paying for, and see if you can't challenge yourself to bring that down. Technology will do it for you in the summer. Technology won't do it for you in the winter. Do not tell people to stop running the water when they brush their teeth. That is the most lunatic thing, compared to the thousands and thousands of gallons you put on your lawn and the gallon or two you may use over the course of a week. It's fine to tell the kids to do that. It's a good thing to know and appreciate. Don't leave the water running while you're cooking and all that kind of things. But there are really simple things we can do that respect the water, conserve the water, don't pollute the water. Let me just get back to your question. I don't give people advice on water treatment technology. You can get your water tested. If you're on well water, get the county health department to sign you up for a free analysis, or you can go to commercial labs that test for drinking water. They'll test for whatever you want them to test for, and then you see what quality issues you have with your water, and then you'll match the technology with that issue. So not every technology does everything for every pollutant. So you need to match them up. And once you see what your water quality is, there are all sorts of services that will provide you with the technology to do what you want done. Do not buy these little things that screw onto the kitchen faucet. No, no, they do not do what you want it to do. Okay, so you had a question?
Yeah, it's along those lines. You showed some images of reverse osmosis that Suffolk County uses, I think, or Nassau.
Nitrates, yes.
Okay. And some other filtrations. Are those used in problem areas or system-wide?
Well, because we get our water from well by well by well, it's every well that has a problem gets its own treatment. They do not make a home version to treat 1,4-dioxane. So your water supplier is the only line of defense there. But all these others, mostly you can get as an under-the-counter system or a whole house system, and usually consultants or providers, vendors, will give you guidance. But you need to know what your water quality is to really make an informed decision. Don't let them come in and say, we take everything out, don't worry about it. No, you need to know what the issue is, and then go from there. Yeah.
So I guess it's a two-part question. So there's the balance of rainwater to the seepage and discharge from the aquifers. So now with the pumping, one thing is who regulates that?
Well,
pumping? And
okay.
then the second part is if it gets regulated properly and it's controlled properly, will the point where the salt water meets
Can it recover?
Yeah, yeah.
Okay. So the first question is who regulates withdrawals? That's the New York State Department of Environmental Conservation. They virtually never deny a well permit. Well permits are renewed every 10 years. Virtually 99% plus are just rubber stamped. So we do not have a vigorous, aggressive enforcement program. Part of the reason we did the sustainability study was to create the technical tools to allow for really informed decisions about giving out well permits and whether permits need to be changed from year to year.